Good day everyone. Members from Group 4 are going to present the topic, Immobilised-β-galactosidase catalyzed conversion of lactose on the membrane surface. This video consists of introduction, experimental, results and discussions and conclusion of the topic. This article presents a study on the synthesis of galacto-oligosaccharides, GOS, using immobilized-β-galactosidase, beta-gal, in a membrane reactor system. The system is designed to enhance lactose conversion efficiency by partially separating the reaction products and the galactose inhibitor. The findings have potential applications in GOS production and lactose hydrolysis. Then, we will continue to discuss the experimental section. There are 4 parts in this section. The beta-galactosidase, beta-gal, was immobilized on the lumen side of the membrane via covalent bonds. The immobilized enzyme reacts at 55 degrees Celsius with rate at 5 milliliters per minute. The TMP between the lumen and permeate side of the membrane was generated by regulating the pressure regulator valve. There is the presence of saccharides. The saccharides were analyzed using liquid chromatography. The rate to separate the saccharides is at 1 milliliter per minute and 85 degrees Celsius. Then, the concentration of the sample was evaluated by comparing the peak area with the external standard. The conversion of lactose from the catalyzed enzyme, beta-gal catalyzed, needs to proceed with some other reactions that lead to the formation of few compounds. There are a few equations that need to be solved to obtain the value of parameters by nonlinear regression of the equations with the experimental data. The production of minor products was assumed negligible. There are several mass balance and continuity equations in the membrane reactor system. The purpose of solving the equation is to find molar flux. All the terms needed are diffusion coefficients of the solute, reaction rate of the solutes, solute concentration and velocity vector. Next, we will discuss the effect of transmembrane pressure, TMP, and the reaction rates profile on the results of the experiment. The results show that the highest GOS yield and lactose conversion at a TMP of 0.5 bars. From the table below, we can see that the GOS yield is gradually increased when the external pressure is increased. However, the GOS yield is decreasing when TMP higher than 0.5 bars is applied. When the external pressure is applied, the mass transfer rate of the solutes to the catalytic site of beta-gal mobilized on the membrane surface is faster and thus the reaction rates are increased. The mass transfer rate of lactose is initially increased and then decreased when the TMP is higher than 0.5 bars. This is due to the gel layer being formed on the membrane layer when high external pressure is applied. As a result, the mass transfer of solutes such as lactose through the membrane is decreased due to larger back diffusion force since the larger solutes are sieved by the pores. Hence, the absorption of lactose to the catalytic sites is interrupted and the reaction rate is reduced. This result highlights that the influence of mass transfer of the solutes to the biocatalytic membrane surface is the determining factor to obtain a high yield of GOS. The reaction rates gradually increased in the axial direction of the fiber membrane, with highest rates indicated at the outlet side for all of the saccharides. The beta-gal immobilized on the outlet side of the fiber membrane has a shorter half-life compared to the beta-gal immobilized on the inlet side. Therefore, the inlet direction of the hollow fiber membrane reactor should be alternated in order to maximize the catalytic activity of the immobilized beta-gal. The conclusion of this article: the reaction rate of beta-galactosidase catalyzed lactose conversion is influenced by mass transfer limitation. The optimal galacto-oligosaccharides yield achieved at a TMP of 0.5 bars. The reaction rate when the TMP is lower than 0.5 bars is increasing while higher than 0.5 bars is decreasing. It all happened because of back diffusion of lactose. That's all from us, presented by Group 4. Thank you.